Do we have to look behind us for notes?
Oh, I turned it on. Thank you. Sometimes it just doesn't want to do what I want it to do. Okay, so here we are at the end of, what is this, week 10?
Mm-hmm.
Oh my goodness. And we are going to talk real quickly about stuff that's due, including the construction project, which no, I have not gotten posted yet. Yes, the construction project is going to be due 1 week from today. So let's look at that. We're going to write it out because I just haven't stopped to do it. So we are going to write out what we want done for that project. So hold on a second. Add homework sheets. Here we go. Okay, stuff that's due. Let us talk about it. We've done just a tiny bit of shifting in the schedule, so here's what I have that we've already looked at. Today is October the 29th. So due today, you have the 6.1 and 6.2 handouts. Okay, this is the, the end of October. Halloween's on Saturday. Don't forget to change your clocks on Sunday morning. Yeah, exactly. Extra hour of sleep if you think of it that way. Okay, construction project due in 1 week, 11/5. Okay, I am going to write out for you in just a second what I want you to do based off of the rubric, like Ryan did, because I just have not sat down long enough to get this done. So I'm sorry, but we'll get it out to you today so that you have a week to work on that. The 2 weeks after that is the write-ups for, no, a week and a half. The write-ups for your semester-long project. Hopefully you haven't forgotten whatever topic you're working on. Yeah, I'll change the due date for the construction project. We're just late in it. Sorry, Elijah. It's totally my fault because I'm just totally out of time is what it boils down to. So the write-ups for the semester-long project, you guys have hopefully been working on that. You've got your activities. You've started putting together the teaks that are used in your activities. And then that'll be due. And then we decided that your presentations will be due as a recording. There's no telling me anymore because we decided that we are recording them. And we will load them into D2L in a discussion board. And you will have to have that by 11:20. And then we decided that the discussion boards, you will respond to at least 5 people's. And that will be by Wednesday, 11:25. And that is actually, I think I already have that up and running, the discussion boards for that. So I think I'm ahead on that, yay. So I don't know. So if you want to, yeah, hang on a second, Mary, I'll talk about that. If you want to go ahead and look at the presentations, getting your video put together, whatever software you're going to use, and load it into YouTube, attach your link to a web page, to the discussion post, then you can go ahead and do that. You don't have to wait, okay? And then the discussion boards, of course, you have to wait until other people have posted their presentations, and then you can start watching their videos and responding, okay? But that's up, and as soon as you got 5, you can do it. Just because it's due the day before Thanksgiving doesn't mean wait till the day before Thanksgiving, okay? And then the last thing is your exam 2 is due. We will do it in class on the Tuesday before Thanksgiving, November 24th. So I am kind of thinking you guys will probably want to do a similar thing for taking your exams. If you came to Commerce, you'll want to come to Commerce. If you took it, there you go. If you came to Commerce, you'll want to come to Commerce. If you took it in Mesquite or in Navarro, you'll want to do the same thing. It's only about 3 weeks out until, November 1st is Sunday. So we're talking just about 26 days until this happens. So start thinking about exam 2, start thinking about how you want to take that, and if anything changed from the last time, let me know. Otherwise, I'll just kind of assume that we're going with the same stuff. Okay, so some comments. Let me do this. Let's start with the construction project. The rubric has been up for quite a while in your thing, in your D2L. The problem is that I just haven't updated it to not say Geometry Sketchpad and just say GeoGebra instead and all that. So let's get your actual construction project, the assignment. Okay, and I think you can probably reconstruct this from the rubric. There's 2 parts. One is by hand. Okay, you will show how you, by hand, duplicate a line segment. Duplicate an angle. Construct a perpendicular bisector. Construct an angle bisector. And the last one on there, which is really, really funny, trisect an angle.
Funny.
Always fun. Fun, I should say. Trisect an angle. And it says in there, tell you that you couldn't do it is an option. So this one, we haven't done anything like it in class, as was mentioned a minute ago. We have bisected angles, but we have not trisected angles. So you might think about what it would take to get thirds of an angle. So if you were given angle A, B, C, okay, instead of the bisector that goes through here, you're wanting to make thirds out of it, something like that, okay? So some people find that Googling on the internet helps them to see a really complicated process. That's okay. You're welcome to try that and duplicate it and see how much you can do that. It ends up being a whole lot of arcs, I will say that, circles, okay? So trisecting an angle. There are some other thoughts that you could do that deal with fractions of angles. For instance, I heard somebody saying, well, Summer, I'll pick on her, that if she bisected this angle, she'd have 2 equal guys, and then she could duplicate one of them. That would give her 3 equal angles. However, that's not trisecting the original angle. So, but maybe we can work off of that somehow. So look some stuff up. We haven't done this one by ourselves or in class. You would have to do it by yourself. It used to be thought that you could not trisect an angle, but you can. It's just complicated.
So writing that we couldn't is not
So
an option.
Mary, well, it's an option. Mary says, could we bisect it and then bisect it again? And this would actually give me 4 angles that are congruent, right? You might use some of that concept to think, okay, what about fractions? Like if a half, we know we can do a half. Can we do something like denominator-wise that will help me see what thirds are, maybe? So maybe looking at 1/6 of angles might help us somehow, or 1/12 of angles. So there is that, but just bisecting and then bisecting again gives me 4 equal angles. Never mind, she says, yeah, 4 equal angles, not 3. So yeah, so there's some thoughts on that. Y'all can play with it. Okay, and then that's what we do by hand, and then by GeoGebra, all the same. Okay, So you're going to use GeoGebra, see if they can duplicate, see if they can construct a bisector, see if they can construct a trisection of an angle, see if there's any of that stuff in there that might help you, and go from there. Okay. And then last but not least, so I'm not going to rewrite all those, but you have to do these both ways. Oops. Okay, all the same. And then last but not least, there is a write-up where you compare.
For each one, or?
No, just your overall experience. My hand versus GeoGebra. Things that are easier for one, things that are easy for the other. How it looks different maybe. It definitely looks different when you do it by hand than when you do it by a software system. Okay. Something that you like about this or you don't like about that. So it's just like about a one-page write-up. It doesn't have to be huge. What's a pain and what's not? Yep. You can definitely talk about that. Put a link and a picture in a single doc. Yes, so this is going to be just like your other GeoGebra projects. So there will be a spot where you can drop it in, and you will want to basically do a doc or whatever version you do with that, and put your link to your GeoGebra file. Remember we did that. It kind of looks at, on mine it's at the top right-hand corner, kind of looks like an angle, and you can click on that and get the link or embed the link and copy that into your doc, and then you'll do your write-up, and you'll have your hand, hand constructions. And you don't have to stick this all into one document, but you can probably make it into one giant PDF and load that, okay? Now I have your submission folder set up so that you can submit more than one file. So for instance, if you wanted to do the GeoGebra stuff, one file, all the write-up stuff, one file, your hand constructions, one file, you could. If you can get it down to one or two files, it makes it easier for us as we're going through looking at stuff, but and some people just stick everything together, that's fine. Okay, so that's your construction project. Is due November 5th. 1 week. And we've been putting that off. Some of you have already been playing with it, I know. So awesome. Okay. Now you have your assignment, finally. Sorry about that. Okay. And then Mary asked, can we go a little more in depth about the semester-long project? So let's talk about that. I have a handout. This is in your, probably like week 2, maybe we did this. And also I have over under content, a little tab for project info. So you can probably find it under there as well. On the file. You're supposed to be, everybody picked a topic, hopefully, if they want to write on. That was due like, I don't know, week 3 or something. So hopefully you guys got that done.
I have mine here if you want to borrow it. Find it.
I think I've got it, but maybe I don't have that file. Thank you. Perfect. I'll give it back. Okay, so you have, okay, pick the topic. Okay, some of you have already gone and gotten activities that you can do in your classroom with your kids on whatever your topic is. Like I'm going to pick on, there were a couple of people who picked dice. Okay, so if you got dice, then you went and found some topics. You have to have at least one book activity, you'll remember, and you found stuff that you can do with kids. I don't care grade level wise. It's just supposed to be something you could use in your future. So if you're 4 through 8, maybe you want something that's a 5th grade activity, that's fine. If you're 7 through 12 and you want something you can do with juniors and seniors, that's fine. Some of these topics lend themselves better to juniors and seniors. For instance, fractals is a pretty advanced math topic, right? So we would probably not do this with fourth graders, but we could do it with juniors or seniors, okay? So pick your topics, your activities accordingly. You're supposed to be picking 2 of them. Okay, here's the write-up. Math 301 semester project. 2 activities or lessons. Each activity should be about the particular manipulative that you've chosen. And I use manipulative in generic, right? So I know that a fractal is not really a manipulative, but it's something kind of an extension of our class that we don't have time to do, okay? So that's why you guys are doing these, so that everybody will get an opportunity to see, oh, this is some stuff I could do with dice, whereas I'm not going to do dice activities in here. But it's kind of a cool 5-minute thing that everybody's going to do a presentation over, where they say, here's what I found you could do, and here's the idea behind it. Okay, inside of this, there's several sections. Section 1, basic introductory information. This is where you just go through and you state what grade level it's for, what TEKS it covers. That's Texas Essential Knowledge and Skills, right? Here's the webpage, TEA.gov. What you think that the purpose of this is. There's a little bit of a citation. I don't really care that it's in a particular format like APA or MLA, as long as I can find what you have, okay? So I need to know the author, I need to know who published it, page numbers for your activity, that kind of thing. Okay, that's section 1, that's just background information. Section 2, the critical review. And this is as the activity is. So for instance, we've got the 5 E's: engagement, exploration, explanation, elaboration, and evaluation. For instance, explanation is the student's opportunity to explain what's going on, okay? They have the opportunity to engage with other people, other students, and talk about whatever that activity is. If the activity doesn't do it, it's okay. You can say, this activity does not give students an opportunity to blah, 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 blah. That's fine, okay? However, you're going to be grading these, basically, okay? So you're giving them a level. It's a Likert scale, 0 to 5, okay? 0 is they absolutely didn't do it. 5 is they did an amazing job, and then you're going to score them anywhere in between, okay, on each of these 5 E's. All right? So that's just your opinion as a future educator, okay? I don't think they gave these students an opportunity to engage. The engagement is like a hook, okay? Did you hook them in, or did you just say, go do this? You know, did you give them a lead in to why this is going to be useful to them, or did you just slap an activity in front of them and be done with it? So, and sometimes that depends on how the author wrote the activity, right? So it's not on you, you're just grading them, 0 through 5. All right, and then the third section is a summary of what you think. This is great, I'd use it just the way it is, and I'd be able to do this and this and this with my students. Or I really think that they should have done this instead, modifications and changes. Very rarely do I pick up an activity and just slap it in front of you guys just the way I saw it, okay? Normally, I'm tweaking it, okay? And that's your opportunity as future educators to do this, to say, oh, you know, if they had only done this, I think that I would have given them a 5 on engage, but they didn't. So you have that opportunity to do those things, okay? That's what you're turning in whenever I say the write-up, okay? That's due November 17th, right? Okay. So that's what you're doing. It's going to be, and it depends on how you write, but 2 to 5 pages. You need to put it in like a 12-point font. Don't do anything crazy that I can't read, like wing ding. Don't, you know, make all your, I know people do weird stuff sometimes. Don't make all your fonts purple, you know. You want this to be easy for me to read and easy to find the information that I'm after, okay? So if I have to change your font to black, then I'm going to be like, oh my gosh, what were they thinking? So make it obvious, okay? Oh, that didn't change. Look at us. We're awesome. November 17th. Good deal. Some things have changed. So. All right. And of course, 2 months ago when I gave you this, you had plenty of time to do it, but now you're kind of getting in crunch mode, right? So hopefully you have not put everything off. Okay. All right. The second part, that's the write-up. That's the most time intensive, I think. That's the most work for you guys. That's why you had 2.5 months to do this, 3 months by the time we get done. The second part is the presentation, and I think we've talked about that a lot lately, so probably you know what you're doing. That one we changed to Friday. I'm writing on your thing, sorry.
Thank you.
November 20th. Okay, so you got just a little tiny extension on that one. Okay, Mary, does that help? Or are there still questions you're not sure about? Thank you, ma'am.
Like you said, we've gone over that part of it, but it's just, sorry, I was making sure it wasn't in here. The time length on those videos.
Yes. So, write-ups, 2 to 5 pages. November 17th. Presentations. Maximum 5 minutes per student. Okay. That's the maximum, and I usually tell people when I hit 5 minutes and you're still jawing about whatever and you haven't gotten through your presentation, I'm just going to stop watching. Okay. So that's not exactly true. If your video is 5 minutes and 10 seconds, I'll watch those extra 10 seconds. But you really don't want to keep on going forever whenever you have a limit. Especially, this is supposed to be a group activity normally. Normally we would have 2 or 3 people, and then you would get more time because y'all could pass the buck back and forth, so to speak. But with it being solo people and everybody's doing their own, you really want to keep it to that 5 minutes. Okay. That being said, I really don't think you can do a good job with a presentation in 1 minute. Okay. So I'm just warning you, 1 minute is probably not enough. So normally people turn in paper or presentations around 3.5 to 5 minutes. And when it's in class, I actually time them. I'll be like, oh, they started at 2:10 and they ended at 2:18. That was 8 minutes instead of 5. That's a little bit long. Okay. But in this, it will be very obvious that your video is however many minutes, right? Because there's a timestamp. So keep it in the limits. 1 minute's probably not enough. That one is November 20th. That answer, Maria?
Yes.
Okay. Mary says helped. I guess just nervous. I know. Everything's due all at once. Dang it. It's the way stuff happens, right? Piles up at the end of the semester, and then you go, when you finish, you're like, oh, deep breath. I'm finished with all that. Yay. Stinking second round of exams. All right. Everybody okay?
I'm very thankful for the optional final. Just wanted to put that out there.
I'm thankful for it too. Because I'm a really bad grader, in case y'all haven't noticed. It takes me forever to grade anything, and fewer people who have to take the final is better for me grading wise. So win, 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 right? I think at least. Okay. Hopefully nobody needs it, and then we just have Thanksgiving and move on. Speaking of that, let me throw this in there. I think I had exam 2 on one of those pages, right?
24.
Yeah, the 24th. Let me just throw out how that's going to look while we're talking about the rest of the semester, the rest of our lives for the next 6 weeks. November 24th, Thanksgiving, November 26th. Okay, that's week 14 for us. And for a lot of you, that'll be the end of this course, because you'll be like, I took exam 2. I will grade those over the weekend, over Thanksgiving, and you should have your grades by the Tuesday. what is that? Is that December 1st? 24 plus 7.
Let me look at the calendar.
Yeah, it's got to be December 1st, right?
Yeah.
Okay. Yay. December, that's crazy. All right, but I'll get you that back. You'll be able to look at your averages in D2L. You'll be able to see how that looks and just make your decision. The way that works is I will give a quiz, one final quiz on this day, and it'll be something about your final exam options. Okay, and it'll be due week 15. Some point. I don't have a date on it. Okay. And you have to take that quiz, whether or not you're doing, no matter what you're doing. And the quiz goes something like this. I have reviewed all of my grades and I am happy with them and I do not wish to take the final exam. Okay. I accept whatever my grade is at this time, that kind of thing. Okay, done. I have reviewed all of my grades and I would like to take the final, and then there will be some options for like when we can take it, how you can take it, that kind of stuff. You're not required to come back to campus to take the final exam. You can take it online. I'll give you Zoom links and stuff like that. There are different time sessions set up already. We have a mechanism in place. And then you can do that. Or if you are in the area and you would like to be back face-to-face, because some people just don't like online, you can come set up some kind of thing with me and I'll have more options there. Everybody has to take that quiz because that tells me whether you're taking the final or not. Okay. After that, my plan is this: week 15, one review video. I'll give out, things that you should look at and that kind of thing, and one Zoom meeting. That's my plan for that week. Okay. So one will be a review video. You can watch all that. And the second one is a Zoom meeting. That way, if you still have questions after the video, you can meet with me as a group or individually or whatever and talk about what is still bugging you for the final exam. And then week 16 is the final.
You said that Zoom meeting, that's if we decide to take the final.
Yes, for the final.
If we opt out of it.
Then you don't have to come to it. Yeah. If you opt out, then you are officially done whenever you take this quiz. Does that make sense? Okay, I got some notes. Will we have the grade for this project before the final to see if we like our grade? Yes, ma'am. I will make myself create over Thanksgiving. Everything will be in there, updated, and ready to go. Right now, your D2L, there's a couple of homeworks that have been graded. Of course, your exam's been graded and put in. Your quizzes, if there have been a few quizzes, are in there. But you'll notice that a lot of the homeworks are not done. It's because the paper grader and I are not doing our jobs. Y'all should just fire us. Okay. Don't fire us. We'll stick around. But yeah, so we'll get all those grades finished out, hopefully before exam 2, so you have a really good idea even before Thanksgiving. If I can, I'll get your presentations and everything graded before the exam. And yeah, you'll know by the time you have to take this quiz. All right, for sure. Discussion post for the project. The only thing I care about for the discussion post for the project, if you watch somebody else's video, I want you to be meaningful and kind, constructive, right? So it is not enough to go, hey, did your video, you stink. Happy birthday. Make you snort coffee here, sorry. Okay. So it's not enough to do that. And it's not enough to say, hey, you're amazing, great job. Yeah, that's not enough either. So it's got to be meaningful and constructive and kind. So even if you don't like what they did, you can say something more along the lines of, it would have been helpful if you had done this, or I would have appreciated if I could have seen that. Okay. So those kinds of comments help, they're not hurtful. If you think it's great, then you can say something like, I really appreciate the way you did blah, blah, blah. Okay. So a meaningful, constructive time. Absolutely. And FYI, I will read them all. I always read all the posts because I want to make sure you guys are doing kind of a more professional job of that, right? Because you're wanting to be educators. So we have to learn how to do things like that. Not using the vernacular, not text posting. Don't do that. Write it out. I know it stinks, but you can write out your sentences, that kind of stuff. All right. Is this okay? Everybody has a better feel for how the semester is going to wind up, I hope. Okay. Well, yay. I wanted to look at. Oh no. Sorry, Elijah. Just watch the rest of the video. I wanted to look at the 6.7 arc length thing. I told you to look at it before today and bring me any questions. This is your opportunity. Some of these questions look at things a little bit differently. So remind me what we did with arc length the other day. There were angle measures, and there were arc lengths.
We took the measurement of the angle and divided it by the total measure of a circle, which is 360, and that gave us, I guess, like a percentage or what ratio of the arc we have.
Hey, can I get one of those again?
Comments?
Yeah, if you have some.
Just a second. Okay, so Maria said, if we know this angle right here, let's call it ABC, or actually technically it will be BAC. CAB, cab.
What, 73?
Okay, say it's about 70 degrees. That sounds good.
And a protractor if you got it.
What?
They fell out of my backpack.
Oh no, you lost them?
Yeah, like 2 weeks ago, but I don't want to say anything. I was gonna try to make it through, but you really need it with this.
Yeah.
Definitely need
The
it.
same thing happened to me. Turns out my baby had grabbed them and they were under the couch.
And you found them though.
I did.
Just for Summer's birthday, you can have them.
Shout out to some.
That's right. Oh my goodness. Okay, so sorry guys. I know.
Zoomville's not lost.
A little crazy up here in Commerce. Sorry, Zoomville. All right, so we have this guy, and I heard, let's say it's 70 degrees. The arc angle measurements are always what's on the inside, right? Okay, so that's the rotational distance to get me from this side of the angle to this side.
We
Then
have
what?
the radius 10.
Say it again.
The radius, can we label it 10?
Oh, yep. So we normally will need a radius length, 10 centimeters. Sounds great. And I heard we need a ratio of the portion of the circle. What I heard might not have been exactly what you said, but notes. So we have to find out what that fraction is. Everybody remember? So we take the angle that we're given and we divide it, I heard, by the total angle measurement that would be if I went all the way around the circle, which Maria said was 360 degrees. Y'all can blame Maria for this 70-degree guy. She picked it, not me.
Part of the homework, guys, sorry.
It's part of the homework. We're doing a homework question.
Got
here?
us.
It's okay. Where is it?
It's number 4 on 6.7.
Number 4. Okay. Ah, there it is. Cool.
So you're welcome, guys.
That's right. There you go. Shout out.
Tricking her into doing homework for us.
That's exactly why we're doing this. Free homework for Summer's birthday. That's what we got. All right. So the portion that this sector would take up out of the entire circle is 7/36 of the circle. Everybody see that? That's the fraction. Okay, and she wants to know this one, I'm sure, because it's not a pretty fraction, right? So it's not even her fault, it's my fault because I assigned it. All right, so we've got that. Then what? We need another concept,
The circumference.
the circumference concept, right? Okay, which we have C equals 2 pi r or C equals pi d, right? Either one of those, it doesn't matter which one you use. So Summer says that if I have that and I know my radius is 10, then what?
We have to multiply it out and then multiply it by the ratio. So 736 times 2 pi r.
Okay, so 2 pi times 10, that makes it 20 pi centimeters for my circumference. Multiply it out, she says. Do not make this a crazy decimal. Leave it 20 pi. Same thing with the 736. Leave it 736. Don't make it some crazy decimal. These are the more exact answers. We're going to work with those. Okay. So now to get the arc length, what we do is we measure or multiply the portion of the circle that is represented times the overall circumference. And what that'll do is it'll tell me how does this arc length, CB in this case, but that's not what it is on your homework number 4. Okay. How does that compare to the entire circumference of the circle, right? So we're getting the portion that we want times the circumference of the overall circle. Okay. So we just multiply it out is what I heard. 736 times the circumference. I'm going to put that 20 pi centimeters over 1. Just so I'll have it as a fraction because the other one's a fraction. And then hopefully you remember how to multiply fractions straight across the top, straight across the bottom. Everybody remember that? So this is 140 pi. And this is 36 on the bottom. Now that will reduce just a tiny bit, right?
35 over 9.
Okay, 35 pi over 9, she says. I trust in your math, because I don't have a calculator. So 140 divided by 36. They're both divisible by 4, right? So that's what she did. Okay. Leave it like that. Don't do crazy things with it. We don't need to know exactly what decimal. The only time you would not want to know exactly what, like decimal to 2 decimal places or something, is if it says, so this is my answer, unless it says approximate the arc length distance or something to that effect. If it says approximate or estimate or something like that, then I would multiply this out and I'd figure out what decimal that is. What is that? It's like 4 times pi ish.
It's 12.22 or 217, so 22. Yeah, where you
Centimeters. Okay.
round
So then I would kind of round it up. Yeah, round it a little bit. But I'm not worried about that unless they say approximate. And the reason they do that is because it's easier for, say, especially a kid in high school or something, to understand what 12 centimeters-ish looks like than it is for them to see 35 pi over 9 in their head, right? Yeah, so they sometimes you'll see them say approximate so that they can just get a rounded answer. That would be
There's a message in Zoom.
That goes. Yes, ma'am, I saw that earlier. Thank you for letting me know. Have a good weekend. Yay. Yes, ma'am.
Can we work on one from 6.1 or something similar to it? Number 1, because I'm not sure if it's asking for like an exact measurement.
what I want to say before I get off of the 6.7 homework is there are other problems on there. For instance, let me show you. I'm not going to work it, but I'm going to say, let's just talk about number 5 real quickly. There are other problems where you have to use other skills. Okay. For instance, this guy right here is an inscribed angle. Everybody agree? Okay. They want to know about this arc length. I can't do that in the same process I just did because I was working with a central angle. This is an inscribed angle. So you're going to have to either convert from inscribed to central,
Wouldn't that just be multiplying by 2?
multiply by 2 to get you the central angle and then work with that. Or you could do the work and then divide by 2. So it's up to you how you want to work with that. But yes, you would have to make some adjustments. Okay. Sometimes I noticed here on number 6, they give you the circumference and you're going to have to basically undo that circumference formula to come up with some other stuff so that you can figure out the arc length. Okay. So you might need to know the radius, or you might need to know, so there's stuff you might have to do in other problems. So just what, they're not all the same exact process. So make sure you can come at it from different angles, basically. Okay. 6.1 I heard. 80 degrees for that arc, for the angle for the central angle. Yes, sir. What Ryan says, I like it. 6.1 number 1, what's your question? Sorry.
I did basically what we started off with on the other one where we, well, I guess I did it wrong. I need to erase what I did because I used the 54 degrees as the central angle measure, which is obviously not right.
Yeah. So how can I figure out what you want the central angle, right? If you can get it.
You subtract it from 180.
Why 180? Picture looks something like this, guys. Should have used my protractor or my compass, sorry. Y'all should know by now. Not an artist. Okay, 54 degrees down here, and this is omega or W. And that's all they give me? Okay. And they want to know the arc length. Bless you.
Thank you.
We can connect the 2 points, the tangent, to create a triangle.
Okay. And we know that these are congruent because they're radii. And we know that these 2 tangent segments out here are congruent because this forms a kite, right? And we showed that last week, I think, that this is actually a kite. It's small. Okay. So what else do we know? These guys right here are 90 degrees, right? There's a little rule about the diagonal in a kite. One of the diagonals in the kite.
The angles are bisected.
Okay, these 2 vertex angles, right? Okay. So this guy, whenever I look at it, is bisected, and this guy is bisected. And what else do we know about this triangle here?
Isosceles.
It's isosceles. What does that tell me?
The base angles are equivalent.
Those base angles down there are congruent. Everybody agree? Okay, so we've actually got a pretty good amount of work of knowledge here. We just need to know some other stuff. So I might have to work with some of the smaller triangles. For instance, I think I can figure out this guy here. If I look at those smaller triangles.
27, 90, and from 180.
Okay, this guy's 27 degrees and 27 degrees for the smaller pieces, right? Because it's bisected. And Summer says these are 90 degrees, so I just need to subtract from 180 to get that angle.
63.
63 degrees. And that's on both sides, right? Let me put little double hashes there. 63 degrees. Okay. That may or may not help me because those guys aren't being bisected. What else do I have? You know that this is bisected, so those two are congruent.
I think Mary said something.
Oh, here. Could have just had two big triangles, 90, 27, and X. Two big triangles, like,
Well, we wouldn't be able to
Yeah.
have the 90.
27 and 90, and this guy's 63, right? So that's these two big triangles. Can I do, oh, I see what she's saying.
But we wouldn't be able to use the 90 degrees there.
Hold on, she's talking about, let me get some points out here so we can use that. 27 degrees, she's saying this angle up here is 90. So let me give, let's call it KITE.
Yeah, that's what I was looking, that's all I thought y'all was looking at the whole time. I seen the tangents on the 90 degree. So the interior, the eye, would have to do.
Okay, so I think that's the triangle she's talking about, right? So KIT. This bigger triangle is the 27 down here. This is tangent, so we know that, and it's tangent at the radius, right? So we know that's a 90 degrees. I like it. So then we just need this angle. Well, we already figured out that angle. It's also 63 degrees. Everybody agree?
Which means the other side is 63. It'd be 126.
Which means
The
this
entire
side,
angle.
absolutely 63. So how big is that?
126.
126 degrees. Angle, measure of angle
And
K.
then now we can ratio that with the 360 and figure out the arc length.
Ha. So we do know that bigger angle. So yes, the central angle right there, 126 degrees. I like it. Good job, guys.
And I have to ask, is it just a coincidence that 180 minus 54, which is the only angle measure that's given from the tangents that connect, is equal to 126?
Just a coincidence. No, it's not. Why?
Because of the type properties.
Hang on. I'm sorry. It's a little tricky because we're looking at it as both triangles and quadrilaterals. So, but remember that we know the opposite angles here would be 180 minus that guy. So hang on, let me think about that.
Is it something to do like with our tangent angles, like kind of the same property as inscribed angles where they're half the size of the central angles? Or is that just like a coincidence?
I
like Maria
think
said?
that's not what's happening here in this particular case. I think this particular case is because this is a quadrilateral,
It does work out that way.
which adds up to 360 degrees. 360 degrees, right? Everybody agree with that? And because these are meeting at the radius, that makes them be 90 degrees and 90 degrees. We know both here and here is going to be 90 degrees, which subtracts out 180. And that's why we're ending up with this is 54, the 180 minus the 54 gives me the extra angle. So yeah, if we had seen at the beginning, oh, that's a radius and they're like Demondre said, they're tangent, so that's got to be 90 degrees. We could have just said, oh, let's subtract out the 180. Now we have 180. and then we could have subtracted out that whole 54. We wouldn't have had to use all of our chi properties. We still got there, same spot. It should always work both ways. But yeah, we could have easily just said now minus 54 degrees gives you the 120. I think it's very specific to this case because we are meeting at a radius. If we were doing the chord like we did in class the other day and it wasn't a radius, it would not. I think that's the key here is that radius.
Can we talk about another one on that page? We don't have to do it, just.
Yeah, watch out.
On number 6, I feel like it can be drawn both A and B in different ways, like the internally tangent circles or externally tangent.
We haven't done that look. Are we doing what kind of a?
Would it be that they just share like a circumference point for internally, like they're not like in the mid, like B's not in the middle of A, but like they share a, I don't know.
So what's the difference between being internally tangent and externally tangent?
Internally tangent, it crosses some opposite sides of where they're drawn.
What do you mean?
I drew it out. I tried to do like some research on it, and I got a lot of. I got more confused than I was.
Internally tangent versus externally tangent.
I feel like externally would be like the circles are like next to each other touching, whereas internally is like they like B is inside of A, but they share a circumference point, like
It could be, yeah.
maybe.
So, but they give me specific diameters, right? So the A diameter is longer than the B diameter. I'm sorry, I haven't looked at this problem. So. Okay, yeah, okay. So the tangent thing, and actually they have a bit of one drawn up here. So I'm gonna steal theirs. The tangent thing still means tangent. It still means they only touch in one point, okay? So we need to watch out for that. These guys, all three of these circles, what, A, C, and D, B, C, and D, maybe, however you think about them. Those guys are touching externally, okay? I don't see a picture of the internal guy. Okay, so this is what they're talking about on part B. If A and B are externally tangent, what is the distance between their centers? So one picture would look like, and I'm just gonna try to wing it. Let's see if my picture is any good at all. Oh, that's terrible. So that's only touches in one spot, honest. So that would be circle B. Okay, so something like that for internal, touching only in one spot, versus what we have in that other one, which is what they've shown me. So what's the difference here? That's a better picture, at least. If one's internal, then the distance between their centers versus with one externally tangent, the distance between their centers. So what do you think? If one's like basically embedded inside of the other one, what do they call it? Nested, a subset, you know, almost. Then what about the distance between their centers? Going to be fairly small, right? Because they're inside of the one. But if they're externally tangent, then we're looking out here and the distance is going to be larger. So now what? Here, this one, the external one's actually easier because you just need this radius, I'm going to call it R1, and this radius R2, right? And you can just add those together. So you're given a diameter, but you can figure that out. So then the difference is, what about here?
I think with A, the radius of circle A is larger than the diameter of circle B. So like we would just subtract them, like,
But it's not the entire radius, right? So I don't want to subtract the entire radius for B. What do I want to subtract for B? I'm sorry, not the entire diameter. It would be more like R1 minus R2, right?
yeah,
Yeah. So there's my total.
because the center of A wouldn't be inside B for the actual
Yeah,
thing.
yeah. That picture's bad. Need a smaller B. Sorry, guys. Nope, that's never gonna work. Here. Oh. There. Something like that. Yeah.
Mhm.
So it's not going to be inside. I agree with you. Because half the diameter is still bigger than the full diameter of that guy. Half the diameter of A is bigger than the full diameter of B. So it will not be on the other side of the center.
Can I take pictures of?
So this, let me write R1 plus R2 here. You can play with that a little bit and see. All right. You guys are rocking. We need to talk about transformational geometry. We've taken a lot of time today, but that's okay. Don't mind taking it if we're actually being productive. This is our next topic in the syllabus. We were supposed to have started it on Tuesday, and clearly we're still extending our knowledge of circles just a little bit longer. That's okay. So when we look at transformational geometry, nobody's complaining at all about any of my stuff. Nobody said, I can't see that. Okay, when we look at this, transformational geometry, it's actually something we can cover fairly quickly, not in 12 minutes, but we can cover it fairly quickly and wrap it up probably Tuesday. So you already probably know a lot about transformational geometry. So when we do transformational geometry, transforming just means moving something around. And normally there's two different kinds. One is a rigid state transformation. And that just means whatever shape or object you start with, it keeps its size and shape. No matter what you do to it. Okay. So we actually see this a lot, and I'm going to cheat because whatever shape or object you start with, it keeps its shape, size and shape, no matter what you do to it.
I said like reflections and stuff.
She's giving me an example. Yes, like a reflection or a translation or a rotation. You've probably seen those before. If you took our 350 and 351 classes, you probably saw it in their geometry section, right? Not what I thought I brought. These haven't been cut. Usually they've been cut. All right, so what I normally would do, and I'm just not doing it now because of our current no touching anybody person, policy, is I would normally hand out these objects for you to do some stuff with, but hopefully you've seen it in like a 350 or 351 class, 1350 or 1351 class. Here's my shape. Kind of like a giant L. Okay, and we would do stuff like trace this guy. You'll just have to be observers for a second, sorry. We would trace this guy or duplicate him. Oh, I'm doing a terrible job. There he is. And we would say, okay, this is my original. And in order to not lose any of his size and shape, I've already got this thing. I'm not going to cut him down or expand him in any way. I would be able to do a couple of things. One is I heard reflection. Okay, how can I reflect this guy? Okay, does it matter where I flip it?
Mm-mm.
And when I teach this to kids, I cheat. I tell them reflection has the FL in it and flip has the FL in it. Okay, so I can reflect it around any line I would like to. Okay, so that means I could reflect it here. Boom. And that would be my new image. Yeah. This is my copy. Okay, and it's reflected around this line. Okay, but y'all said I didn't have to. I could have reflected it backwards, so to speak. Could have reflected it this direction, right? Around this line. And then my new image would be back here. Okay, so there's a lot of ways I can reflect this guy. As long as I'm flipping it, it counts. Okay, this is a copy. Okay, so those are all reflections. I don't have to flip it along one of the lines that's on the image. Okay, so in other words, if this is my original here, I could just as easily say, hey, I'm going to put a line. Okay. Sometimes I do weird things. I'm going to put a line here. Okay, and I want to reflect it around that line. So I would take it and I would flip it and I'd be like, okay, maybe it's about, I'm just eyeballing this guy, so sorry. Maybe it's about that far off. There's my new image, right? Okay. So it's a reflection. And actually, I've kind of rotated that one too, sorry. Okay, so that's one of the rigid state transformations we can do, and you've seen them all a lot, I'm sure. Okay, what are the other ones? There's two other rigid states. Okay, I said one just a second ago. Yep, rotation, which means not using that word. I'm going to use turn because I cheat. So rotation, they all have the shun part in it, right? So if I ignore that, here's the T and the T, right? So I kind of rotated that one there a little bit and got a little bit of a turn to it. So the idea being that, again, you have your original. I'm going to rotate mine right now around this point right here. Okay, so I pick it up and I just turn. There's no shifting or anything. I just use it like it's a hand on a clock or something like that. One of my rotations could be stopping here. One of my rotations could be stopping here. One of my rotations could be stopping here. As long as this point is basically fixed. The rest of the thing moves. And again, I keep my size and shape, right? Same size and shape, but it's rotated around this point. Right there. Okay. And again, I don't have to rotate it around a point that it's connected. I could have a point way out here, and then I would take my rotation and I would go, okay, let's rotate it like it's going around a clock. Okay. And so if my point of rotation was right here, it would be okay. All right. So I could have an image way out here, and that would still be a rotation. Okay. And the third one, you'll remember it?
Translation.
Translation. And to me, I use the word slide because I want to cheat with kids, okay? And again, the shun, they all have the T-I-O-N at the end, so that part doesn't matter. But look at that, translation has an S-L in it, and the others don't. So that's how I keep them straight with the kids. So that literally just means slide. No turning, no flipping, just slide. And then we know, of course, we can do combinations of all of these, right? Now, I don't have to just slide it side to side or up and down, although those are options. I could slide it like this, right? It doesn't matter what the vector is it's on, as long as I'm not rotating it in any way. So, something like that. Okay. So those are your rigid stakes. And then there's ones that change your size, but not your shape. You guys know what those are? Non-rigid transformations. So in here, the shape would still be the same, but the size can change. There's two of them. And here's my original. Sometimes we call this scaling. Scaling, S-C-A-L-I-N-G. You can do a scale model. Two. Sometimes they're called dilations. D-I-L-A-T-I-O-N-S. If I said do a scale model of something.
Making it bigger or smaller?
Yeah, it's like making it bigger or smaller, right? But it's to scale, which means if I make one twice as big, then I have to make the whole thing twice as big. Every side proportionately, right? So if I had this classroom and I made a scale model of it, it would probably be really small, right? And I might draw it or whatever. But if I divided one side length by 5, then I would divide all of the side lengths by 5, okay? So this is either an expansion, which makes it larger, or a shrinking, which makes it smaller. Absolutely. So the thing to remember is that it must be proportionate. So if one side is half as big, then the others are too. Okay, absolutely. So I'm going to cheat just a tiny bit and try to draw these all half as much. Not quite. Something like that, right? That would be about a half as long on each side. That kind of thing. So those are the basic types of transformations you have. And I know I have at least 2 people in the class who have picked tessellations as their topic. So I don't have time right now, but when we come back next week on Tuesday, we're going to talk about tessellations. And basically what you would do is try to tile an entire area, and I'm not going to get too far into it because people are going to give me great presentations on it so that I don't have to get into it myself. But I would try to see if something can cover the entire area or not. And there's kind of some cool art out there that's based on this stuff. Okay. No new homework tonight. I think you've got plenty to work on. So that's it. Don't take off if you are in Zoomville till I take roll, and everybody else have a great week.